Okay, welcome to the security demonstration of our payments portal. Welcome to the security demonstration of our secure payment portal. Today I'll walk you through each security requirement from the rubric and show you the implementations as well as demonstrate how the application protects against attacks. So for today we will cover password security, input whitelisting, SSL or TLS implementation, protect against attacks, and then additional security measurements that we took during this assignment. So first off, ensuring that our application is running through the terminal, we can then go ahead and open the backend folder. Here at the backend folder source code, we can go to this file so that we can first off start with password security. So with our password security, we have implemented a multi-layer approach. This file contains our password security implementation featuring bcrypt hashing, automatic salting, application level paper, and password strength validation. So with this method, you will notice the 3 levels of security that we implement when a user or a customer register to our portal. So the first layer is the application level paper. The paper is also stored in a secure environment folder where it basically attaches the paper that is secure to the password. That is the first step that we do. The second step that we do is generating a salt with 12 rounds. And then we hash the whole created password with the paper and the salt included, which will then create a unique set of characters that is sent to the database. Basically, when an attacker tries to figure out what a user's password may be, it will never be stored as plain text and thus increasing the security of what it will take to actually break this. Also, looking at it at the database, you will never just see plain text because it went through all these methods, these layers of security of adding a paper, adding 12 rounds of salt, and hashing the password so that it is always a unique character that can't be guessed. The second thing that we implemented was verifying of password. With this method, we basically just ensure that when a customer is registering, as you can see here, when a customer is registering, that they don't put unnecessary characters or accidentally misspelling their own password and thus forgetting it, just confirming that they know what they put into the system. So before registering, they get to confirm their password, and we also use error handling to ensure that both passwords are correct before a user or a customer is registered. The second thing, or the third thing that we implemented is the validate of password strength. There is basically a list of policies that a password has to adhere to before it gets to register the customer with its password. So a password must be a certain length, 8 characters is usually a pretty standard password. It must contain one upper, one lower, at least one number, and a special character to ensure that the password is hard enough so that it cannot be deciphered by a hacker. All of that ensuring that it is a valid, strong password. If you also look here at one of the methods that we have included, is showing the strength of a password to the user, ensuring that they always have a strong password. So if we go ahead and we put in pass, then you will see it all contains lower cases, which is correct with pass, but it still needs to adhere to all these policies and it's a weak password, so you are at risk. If we retry that with a harder password or a password that has all the policies, then you will see it will return a strong password. Not the strongest, we can make it even more stronger. There you go. But as is, it must be a strong password for a customer to register. And that is how we create password security. The second thing I want to talk about is the whitelisting. So if we go here to our middleware and input validation, it will open the file with all our methods for input validation. In this file, we have created patterns that gets to be compared against the input that the user will enter before they submit any form to the database, to the back end, to any of that. It will first go through our input validation form. This is then where the text that is inputted will be compared to the pattern, ensuring that each and every input adheres to what is allowed to be submitted. So we also have dangerous patterns, as you can see over here, that looks out for malicious attacks. So for example, with the SQL or the SQL injections, our input or Rex pattern will literally look for words containing delete, update, drop, or anything that can alter to our backend when a user submits a form. Also, in this file, we also have sanitizing, which basically helps with cross-site attacks, ensuring that it is also valid information that is added. So all inputs are sanitized with HTML entity encoding, which basically means we remove null bytes or encode special characters and trim any white spaces, and this will prevent attacks even if it's malicious input when it is bypassed with the initial invalidation checks that the input goes through. And you will also see that each input will go through a set of criteria before it can be sent to ensure that it is all validated before it reaches the endpoint. So the next thing that I want to talk about is the SSL or the DSL implementation. You will see that we have configured SSL certificates already. And even though they are not submitted in a real life application or example, it should usually be generated by the user their own certificate. But just for educational purpose, I wanted to show you the certificates that we created with OpenSSL Serve. So it is a standard TLS 1.2 plus with a strong cipher. As you can see, it generated a huge bit of data that can be used. And then if we actually go to our server file, you can then see how we implemented it to ensure that our application runs with the SSL certificates. In this file, you will also see that we implemented Helmet. Over here, we implemented Helmet. With Helmet, we basically enforce that HTTPS must be used and any downgrade of attacks is not allowed. So it prevents any downgrade attacks. While using Helmet, it creates this and forces the headers to basically use HTTPS and also with the TLS. So it enforces our browser to always use this, or else you won't be able to view our site. So now what I want to do is just quickly go over how are we preventing certain attacks. So the first thing I want to talk about is session hijacking prevention. So if we go over to this file, or authentication middleware, we can have a look at how we implemented and protected against session hijacking. So with session hijacking is when an attacker steals a user's session token. This is typically through cross-site attacks or man-in-the-middle attacks or anything like that, and then the attacker gets to impersonate that user and gets access to very sensitive information and data. So we have the token, the JWT standard token that is generated for each user, but to keep this token safe, we also added an expiration date. So over here you can see we generate a token, we verify that it's the correct standard of token, and each route is then protected via this token. But what is important to note is that there is an expiry to our date, and with this 24-hour expiration, it reduces the hijacking window. We included specific issuers and audience claims to prevent token reuse across applications. So tokens are validated on every request, checking for expiration and tampering. And we automatically invalidate tokens when password change, and all tokens are transmitted with the HTTP request that we created to ensure they don't steal your token.